So in this video we're going to talk about normal distributions, and I did an experiment with my bass where I played a note on the open E string and let it ring out. I recorded it on Audacity, and you can see that here, and I could see how long it sustained for. I did this multiple times and tabulated the data, and you'll see that in a minute. That's not such a nice note, that one. So you'll see I did it on Audacity here, so I can look at the waveform and determine how long it is from this when it first sounds till when it attenuates away. I then recorded the start and end times in a spreadsheet and could work out the duration of each note. From that, I could create a histogram that showed that these notes are fairly well normally distributed. And I could also work out the mean and standard deviation for the length of these notes. So knowing that the length of these notes are normally distributed with a mean of 7.263 and a standard deviation of 0.355, we can answer questions like this. What's the probability the note will last in less than 6.5 seconds? Now, we could use z-scores for this in tables, but we live in the 21st century, so I'm going to use a calculator. And I'm going to put this normal CDF with my limits from 0 to 6.5 seconds with my mean and standard deviation here. And that gives me 1.6% answer there. How about it's more than 8 seconds? Same thing, 8 to some big number. As long as it's 3 standard deviations away, it doesn't matter. I just put some big number, and then you get a similar answer. So it's more likely to be longer than 8 seconds than shorter than 6.5 seconds. What about between? Again, it's normal CDF. It's all normal CDF. I'm using a Texas Instruments calculator, by the way. So 7 to 7.5 with that mean and that standard deviation is about half the notes are there.